Okay, so the first one was what are isobars, and I kind of feel like we've hit that a few times, but isobars connect locations of the same pressure. You guys have already done this. And how is wind created? It's basically air relocating from a high to a low pressure. And then the next one goes with how is wind created. So we call the pressure gradient force is basically in the same direction as your high to low. Pressure gradient force is in the same direction as your air is moving. So pressure, PGF stands for kind of that force that is why air wants to move from a high to a low.
So it's the force behind it.
Right. And then the next one kind of goes with it. With regard to on a weather map, if you see the isobars are really close together, we call that a tight pressure gradient. And if the isobars are close, you would expect strong wind. So that's the first one. If the isobars are far apart, we call that a weak pressure gradient. And you would expect weak winds, slow winds from that. And then over here on the right, I have what's up about Coriolis force. So the Coriolis force is created because the Earth is spinning. If the Earth weren't spinning, we wouldn't have this Coriolis force. What the Coriolis force does is it makes air move to the right in the northern hemisphere and to the left in the southern hemisphere. And then when we talk about hurricanes, this is actually going to be a player. The Coriolis force is like at the equator, is strongest at the poles. Coriolis force is strongest at the poles and weakest at the equator. And then
you say left or right, is that if you're looking at the equator?
That is if you are moving with it's wind, so you're moving with the wind.
Yeah.
So it doesn't matter if you're moving, if you're going towards the equator or away from the equator. Like if you're going from the poles to the equator, it's to the right. If you're going from the equator to the poles, it's also to the right. Yeah, to the right, almost to the right. Yeah. We've got a dog right now who's special needs, and he was born like with a mental thing, so he couldn't stand. He needed to be bottle fed and everything, so he can stand, almost even run now, but he like leans to the left. Like, so always leaning. My husband's like, at least he's leaning the right direction. He's leaning to the left. So deflection to the right. Friction. A lot of times you already kind of know what friction is. Friction is basically created by roughness. And one thing with regard to wind is the Earth's roughness. So friction, I have works opposite motion. If you can't read that last word, it's motion. Friction works in the direction opposite motion. And then we have two winds. We have gradient wind, but we have geostrophic wind. Geostrophic wind is on your test. That geostrophic wind, we just looked at geostrophic wind. It's that wind at upper elevations that kind of goes with the jet stream. That's geostrophic wind, generally from west to east. So geostrophic wind blows relatively straight between the isobars. And I said at, what did I say? At upper elevations. I know. Upper elevations. Looks like upper divisions. Yeah, upper elevations. And so this geostrophic wind, especially at upper elevations, is just kind of generally between the lines of latitude. And then for the next one, I made kind of a column of high and low. Of course, our highs are anticyclone, our lows are cyclone. For highs, you think of air as leaving the center. I'll use the word diverging, leaving the center. Diverging. Low surface lows are airs coming into the center. Highs are moving clockwise, lows are moving counterclockwise. Highs bring clear skies, lows bring cloudy skies. The next one, wind direction, is generally speaking, it's named after the direction the wind is coming from. So if we say we have a westerly wind today, the wind is coming from the west. And it does look like it's clearing out there, Joshua. Might see the sun today. The windrows actually is kind of a cute little icon that has lines to it, and the longer the line, then it means from that direction the wind is blowing more from that direction. The Bayes-Ballott's law works best at upper elevations, and it's all about the L. So if you think of the wind at your back and you hold out your left hand, then that's where your low is going to be, with the wind at your back. And that means the high is going to be on your right. And then the last one, we talked about different ways to measure the wind. And the one that can actually give you wind direction and wind speed is the arrow vane. So down in the red there, wind, arrow vanes give wind speed and direction. Then on to chapter 7, the Santa Ana winds. They're associated with the Rockies or the Sierra Nevada mountain range. Bless you. And it's on the Pacific Ocean side of those mountains. Remember Dirk kind of talked about how you have a high pressure. Okay, it's a down slope wind. And the thing with Santa Ana winds is because of the season they occur and where they occur, they can actually aggravate forest fires. Chinook winds are also associated with the Rockies, but they're on the east side of the Rockies, Chinook winds. So they're also a downslope wind. And is that anytime you get air to move down, it gets warmer. So they're both warm, dry winds. I brought in a figure for the next several ones. This is the figure I joked about putting under your pillow. If you haven't done it yet, it's probably too late. So anyway, we've been talking about the 3 different cells in both hemispheres. I think it's 6 cells. And the major features, like the intertropical convergence zone is where the 2 hemispheres meet, the 2 Hadley cells. The doldrums are also associated with the intertropical convergence zone. The doldrums are kind of those light variable winds. Okay. Semi-permanent highs and lows. We have semi-permanent, they alternate. So we have a semi-permanent high between the Hadley and the Farrell. And then we have a semi-permanent low between the Farrell and the polar. Monsoons. Of course, the most famous monsoon is the one in India, but in general, you have a monsoon occur if the winds will switch seasonally. And then because of the winds switch direction, they bring precipitation during the warm months and dry during the cold months. The reason that the oceans have currents is because the wind is moving to move the water. So, oops. So upwelling is that cold, nutrient-rich water coming up from, I put the ocean deep. And in order for upwelling to occur, you need to have a nice, decent, strong current. And then this was that number 9. Number 9 question for this chapter said, why do the west coasts of continents generally have cold water? And you can either put upwelling, which a lot of you did, or you can put what I think of is it has to do with, I put my orange H's here. We have a high here, a high here. We just talk about the North Pacific and the South Pacific. In the Northern Hemisphere, we know that air and water is going to go clockwise. In the Southern Hemisphere, it's going to go counterclockwise. So in both of those cases, we have cold water coming up those west coasts. And that would be the same for any ocean basin. So, all right. Next chapter, air masses. So in air mass, we focused on air temperature and air moisture content and came up with 5 air masses. And air mass is uniform, I kind of put horizontally. If you go up in the same air mass, it is going to go ahead and change slightly. Source regions. A source region needs to be large, uniform, and needs to allow, it can't be too busy. It needs to allow for a chunk of air to sit. Then I brought in these 2 maps of source regions. The left one's winter, the right one's summer. So source regions, we have kind of the, in the winter is the only time, and I have an asterisk, or I circled it, in the winter is the only time we get the continental Arctic air mass. In the summer is the only time we get the continental tropical air mass. Okay. And then with regard to the 5 main air masses, hold that thought, they look like, Here's that table I had in my notes. Unit 3, sending project. Dun, 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 dun. All right.
Oh, that's busy.
It is. Whoops. Okay. There's our source regions. There's the map. There. There was the table I was talking about. So you have several, and they're mostly, I think, multiple choice questions, kind of about the different air masses. What would their moisture and temperature be like? Okay. Air mass modification, it makes sense when after a chunk of air leaves its source region, it's going to start to pick up the characteristics of the land it's moving over. And so that's why I say it will exchange heat and or moisture as it moves. The dry line, and I think when I passed out your review sheets the other day, I kind of apologized. Dry lines actually are a type of front, and they're covered in Chapter 9, but they made it to your Chapter 8 for your review sheet. So dry lines are a type of front between two air masses. They're both warm, but one of them's dry. So it's continental tropical and maritime tropical. One of them's moist. So.
Is there a dry line with today?
Not that I know of.
Okay.
So one of the reasons, see, continental tropical air only forms in the summertime.
Yeah.
So, yeah,
Okay.
don't have those.
Does
We-
something form along the dry line? Or-
Yeah, dry lines, when we talk, when we kick it off with severe weather, dry lines are great for lifting up that dry, warm air lifts up that dry, or that moist, warm air and causes crazy activity with regard to thunderstorms. So dry lines are great for thunderstorms. And then the last chapter, a front is basically two air masses are meeting, and it's the line between the two air masses. It's the boundary between two air masses. The four main weather fronts, not including dry line, are up there, kind of from left to right. We have occluded front, stationary front, warm front, and cold front. I think it's cool that even if you're colorblind, you should be able to kind of look at the icons where they're at and know what you're looking at.
We were watching the weather last night, and I saw those, and I was like, Dad, I know what those are.
Let me tell you. Study for the test. Good. Overrunning is associated with warm fronts. So with overrunning, the deal with a warm front is the warm air is trying to move in on cold air, which is more dense. So it kind of goes up and over. Okay, and so that gives you your overrunning. Then here is actually up in the upper right-hand corner, a warm front, and kind of showing you in advance of the warm front, you can have these stratus clouds. So first you'll have cirrus, then you'll have cirrostratus, altostratus, you might have stratus, and then nimbostratus as the warm front approaches. Mid-latitude cyclone stages of development. So I know it's really small, but here is kind of the stages of development we talked about yesterday and kind of started out today. This is assuming that it starts with a stationary front, and then you get a wave, and then you get, it breaks out into its fronts. And then here, I don't know if you can see that purple, actually you have a little bit of occlusion here. The occlusion is elongated, and then it kind of goes on this way. So viewed from a satellite, it looks like a comma. So I put equals comma up there. And then last but not least, those last two go together. Okay, so the upper level ridges, troughs, and surface conditions explain the relationship between surface high and surface low and air loft. So, I must have narrowed that down for you. It's cyclone, not anticyclone. So that's hopefully kind of fresh on your mind what we just talked about. Okay? Very good. Well, good luck studying. It will be fun.
We should pause